The Defense Advanced Research Projects Agency, DARPA, formerly ARPA, was established in 1958 in response to the launch of the first satellite, Sputnik, by the Soviet Union. DARPA's mission then and now, create or prevent strategic surprise.
So DARPA's mission is certainly strategic surprise, technological surprise, but its surprise could be very hard to predict.
Hard to predict because computers are being used in more and more things we own, so more and more programming code is being written. Refrigerators, washing machines, baby monitors, smart homes, all app-controlled from our computer phones, populate our lives. It's called the Internet of Things.
Now the thing that we've got to do is figure out how to make these systems more secure because we are relying on them for more and more.
The big takeaway is that there is a vulnerability for a very manageable number of lines of code, and there's so much code that's actually written every day that it's very easy to see this as an infinite problem.
IBM Rational made an estimate of the number of lines of code that our civilization is running, that it crossed the trillion lines of code in the mid-2000s. That does not count the number of times that those lines have been replicated and turned into binary code and stamped into chips that can no longer be updated, and those chips have been put into things, and those things have been distributed around the world.
Does that mean we've got a billion vulnerabilities? Like, I can't wrap my head around a trillion lines of code. I can't wrap my head around a billion vulnerabilities. That's a gargantuan problem.
Gargantuan and increasingly concerning.
You can think of the Internet of Things in two distinct groups. There are conveniences, and there are the things that are critical.
Smart power grids, water supplies, traffic lights, air travel are all computer-controlled, which intruders could shut down.
And at DARPA, because our job is to prevent strategic surprise, right? Because that hasn't happened, that kind of physical breach of trust on a very large scale, we need to start building solutions now before something terrible happens.
As soon as we cross that point, we'll see if he could.
We are having a competition. We are trying to spark automation of tasks that are exclusively the domain of people. But what will come of that is largely unknown to us.
The Cyber Grand Challenge, the CGC, will be a fully automated capture-the-flag contest with computers pitted against computers. Humans will program their machines and then step aside to watch them play the game before a live audience.
And we can decide the good ideas based on competition. We can determine the bad ideas based on competition. It's a challenge. It's great. And at the end of a challenge, we know what works and we know what doesn't work.
Everybody will get some little piece of it right, and they'll learn from each other. And prototyping on a very quick deadline can have enormous results.
That's what the Cyber Grand Challenge is trying to do, is to understand to what degree can we build these systems that stand on their own.
And hence, with the CGC also with our research in general and with our collaborators, it's about developing techniques to help us to improve security even when we have complex software.
We don't know that the Grand Challenge will be successful. We don't know that, that we'll see a viable proof of autonomy, that there's even proof that automated bug checking and proofing and patching has a future with current technology. But we've done everything possible to set the stage for that, to have an open call for innovators to make sure that top talent from around the world is working on the problem. And certainly we can hope for that. The end result is not the answer, it's just the beginning.